Hello, my name is Adam, and this is Newton's 3 laws. Now let's get started. Newton's first law is an object at rest stays at rest, and an object in motion will stay in motion. Newton's first law is also known as the law of inertia. Domino. When the first domino hits the second domino, it transfers its force to it, then causing it to fall over and do the same thing to the next domino. This repeats itself until the final domino hits the floor and transfers force to the floor. Now the dominoes are at rest until another force is acted upon them, which shows Newton's first law. Now let's look at demonstration 2. Jumping on a trampoline shows Newton's first law by showing the force of my body acting upon the force of the trampoline. When I jump onto the trampoline, the force of gravity pulling down on my body pulls down and distorts the trampoline. The force from my body is then transferred to the trampoline. The force transferred to the trampoline is spread to the springs where they begin to pull back. The force is transferred back to me since I was not moving, and it pushes me up. This transferring of energy between the trampoline and I shows Newton's first law. Newton's second law is the acceleration of an object as produced by a net force is directly proportional to the magnitude of the net force, in the same direction as the net force and inversely proportional to the mass of an object. Summary: less force, less acceleration; more force, greater acceleration. Newton's second law is known as the law of force and acceleration. A fan blowing a boat shows force and acceleration by the force of the wind affecting the acceleration of the boat. When the fan is at its highest setting, it is using the most amount of its force to produce the wind. The force from the fan is transferred to the wind. The force from the wind is transferred to the sail of the boat, causing it to accelerate at a high speed. When the fan is at its lowest setting, it uses little force to produce the wind. The force is transferred from the wind to the sail of the boat. The boat with the lower force has a lower speed than the boat with a higher force. This difference in force between the fan speed causes a difference in acceleration for the boat. Balloons with differing amounts of air will affect the acceleration of the balloon down the wire. The balloon with 8 blows of air exerts force from the air pressure in the balloon, pushing it forward. This is because there is more force from pressure in the balloon. The greater force pushes the balloon at a faster time to the door. The balloon with 3 blows of air has less force to push against the air since there is less air pressure in the balloon. The balloon will travel slower with less acceleration than the balloon with 8 blows, so it will take more time for it to hit the door. Newton's third law is, for every reaction, there is an equal and opposite reaction. The forces are known as action and reaction forces. A ball falling and pushing against the ground shows the force of the ground and the ball pushing against each other. The force of the ball hitting the ground pulls its body to the ground, causing it to flatten out. This force is the opposite force acting on the ball. The opposite force is greater than the force of the ball pushing it against the floor, so the ball bounces back up. This is showing 2 opposite forces between the ball and the floor to show one force overcomes the other with the opposite force. A weight pushing on an egg shows the force of gravity pushing against the shell of the egg. The box with the candle lid of weight pushes down on the egg with the force of gravity. The force of gravity is opposite than the force of the shell, which is pushing against the box, and is stronger than the force of the box, causing it to stay okay. The box with a water bottle pushing against the egg is the opposite, but the force between the box and the shell aren't equal. This causes the box with the water bottle to break the egg and causing it to break. This is showing the opposite and equal forces of different box masses on the opposite force from the eggshell.